Hello. Just small correction. I'm not the global head of AMR. I'm just an architect of the global head of AI and ML. Quick disclaimer, just because I'm coming from a highly regulated environment, so all the opinions are my own, and any answers I'll be answering will be my own opinions. So just to make sure we're covered there. Now. As you well know, AI and ML is not really a new paradigm, but within the regulated environments, we're still trying to do, kind of figure out how to do it right, and kind of the industry main kind of patterns for robust production deployments are kind of rooted in software developer lifecycle. So, having your kind of dev test prod. Now, it's nice, but in a highly regulated environment, that kind of is an issue because you can't actually have kind of combining production data in your dev is something that gets kind of control governance people had implode. So we had to do something, and kind of this is where I'm going to show you some of the journey and a reference architecture on how we're kind of thinking about it in JetRemote. This is a general AI/ML kind of a architecture platform rather than specific to computer vision or AI. Now, I'm gonna start just from kind of covering some of the kind of risk dimensions in respect to SDLC versus kind of MDLC. There's kind of people tend to say, well, you can do MDLC and SDLC. Well, the risk is different. So we're gonna touch on that, and then kind of how to combine those two approaches where you have the existing systems with existing thinking and existing people that think about those kind of controls and governance and how to bridge the gaps towards the new world. And we ended up kind of a quick kind of a spoiler. We ended up defining a new AI and ML environment. So just a spoiler just to kind of help with getting to the last slide. So I kind of mentioned a bit about dev test prod, but just beyond that, if you just think about ideation, right? So in standard application, you have an idea, you go in prototype, kind of spin up your dev environment, kind of do your thing, do your mocks, prove your point, getting a plan, start executing, nice and easy. Well, in most cases. In AI and ML, ideation is actually, as some of the presenters outside was showing, does kind of, only 30% get to production of the projects get to production. Well, in regulated environment, a lot of the projects don't get to be ideated because they're not approved because of governance-related constraints. So people just, it takes so much time. So by the time you get an approval, people move or forget what was it about. So ideation is really critical because that's essentially the first step. If you don't have the right way to do the first step, you cannot do the end-to-end delivery, as Ahmed was saying before. And it's extremely important to kind of make sure you have a route for full delivery rather than just the first step. Now, beyond deterministic versus probabilistic and kind of mocks and real data, amount of time is also very different, and obviously the money spent in ideation. So be able to use real data with especially kind of for kind of computer vision, but in more general for the newer kind of deep learning models, it takes also a lot of money. How do you measure it? How do you kind of govern it, etc. Operationally, as I was suggesting, kind of the risk is actually kind of somewhat different as well. So you can have an app running in production, and assuming you did your unit test and all that kind of stuff, as long as it doesn't return 500, you should be mostly good. Whereas if you have a model running in production and returning 200, but it drifted, then it's better that it would return 500 instead of just doing damage, kind of depending on the use case. Monitoring of operational systems is also important. I think kind of for people kind of in standard SDLC world, they say, yeah, you need to kind of monitor CPUs and storage and whatnot. But you also need to monitor features and model performance and drift and all that kind of stuff, which are additional type of monitoring that are not really available in the standard software developer lifecycle kind of tool set. So what is the risk kind of that people kind of, the risk people or the controls people. And controls are just, things that think about as just non-functional requirements you need to implement and evidence, because I'm going to use this word a lot. It's a fancy word in government industry, but it just means non-functional requirements you need to address. So in software developer, you have, standard kind of cyber risk like data exfiltration or kind of, mutation or reintroducing of bad data into your production system, kind of hacking, kind of users hacking your systems and then doing, what's not supposed to, what they're not supposed to, like Bitcoin mining. Obviously kind of with open source and third-party libraries to be able to, make sure that bad libraries are not getting into your system, or if they do, you can track them, monitor, and remediate as soon as possible. And traditionally, at least in some of kind of the regular environment, the solution was we want to do as much as the checks we want up front. So that's kind of the shift to the left, right? And lock down the production as much as possible. Well, that's nice. In MDLC, it's somewhat different, right? So if the risk of not having access to real data is you ended up with a crappy model or, something that has different types of biases. If you have a stable model in production, then you do want to actually replace it as soon as possible, ideally without going through, the gates of hell to get there. Again, in highly regulated environments. And similar way with third party and open source stuff, you have models to worry about, which is a whole ball of kind of different stuff, because you can't actually know necessarily who created what it created. If it's translation, maybe someone added profanity to one of the languages, who knows? But kind of to actually kick off the project, you need to be able to shift some of the controls to the right. You need to be able to ideate until you actually have an idea that is tangible, and then start applying the controls. So kind of that's where SDLC and MDLC kind of start conflicting, at least in some of those kind of companies. You also want to kind of start supporting, well, I want to do shadow models. I want to deploy. I want to test in production without impacting production traffic. How do I do it? Again, kind of it implodes some control people minds. It's like, do you want to do what in production? I'm gonna skip forward. So in terms of the process, we went through kind of to fix it or try and fix it is people, process, and tools. And unlike in other places where you have people, tools, and process, or in other kind of presentations, the order here is important, because you actually need to fix the process. And the tools need to be created for the process or to automate the process, because otherwise, you're just creating tools that will not necessarily solve the problem or accelerate it. So people. So kind of we spend quite a bit of time working with our kind of control and governance people to just explain to them, what are the different activities that are happening, kind of, like you do interactive kind of process it. You need to look at data, you need to understand it, you need to analyze it, etc. It requires real data, not mock-up, not whatever. You need to actually do it. And what the outcomes you'll get if you do that, well, the models will be better. You'll not be able, if you just mock up data or simulate it or synthesize, you might be able to see X versus Y. And that actually is a risk, because you kind of spend a whole bunch of time, you spend a whole bunch of money, you have then deploy something in production, and that's a problem. And then kind of thinking with them together in terms of what do they think is the risk that we need to mitigate? Because in a lot of those cases, they're actually reasonable people, and they say, well, I only care, not only, I mainly care about data exfiltration and not mutating production traffic. If you give me an environment that kind of makes sure you cannot impact real production data, then just go ahead, making sure you have this kind of one-way sandbox effectively to some extent. That might be fine with them. There are kind of different patterns, different companies, different regulators, different environmental conditions within an enterprise that might fit. But having that discussion is extremely useful. Instead of kind of, when it comes to the process, it essentially once you defined those, kind of define those activities, you can kind of work with them to kind of say, well, who is actually doing those activities? You have humans, like, doing the interactive stuff. You have a lot of automation, because unless you have automation, it's not really a repetitive process. And, most of the kind of large-scale model training cannot be done just by kind of clicking cells in a Jupyter notebook. You need distributed compute to kind of run those, which requires some level of automation. So be able to kind of capture those activities, expectations, and create those mappings of this is human versus not human, with an end goal to actually create a lineage. So if you produce an artifact from, by a human, it has a certain level of credibility, let's just say, versus done through automation where, someone kind of jump through hoops and kind of just to make his model perform better. So there's kind of less risk of that. And this is essentially to create this evidence chain of, hey, this model, I know how it was created through automation process. I know where the data came from automation processes. I know kind of the source of the data. It's an appropriate source system. I know the quality of the data. I know everything about it, start to finish. And that's super, super important, because they don't know we can't do it. And there are tools that do it. There are many tools that, there are different vendors, or you can develop it yourself as well. And then kind of make sure you actually define the outcomes, right? Because the outcome is super important. If they don't understand the business value, then they'll say, well, I want controls. Well, control for what? Your control actually blocking progress. If we cannot do it, there's no business value. There's no business value is what we're doing here. So it's a fun kind of discussion to introduce business value, because it allows you to kind of make sure they understand that it actually impacts, and what kind of tying everything to the impact that your activity kind of brings into the whole picture. And then kind of different type of kind of mitigation techniques, kind of automation versus not automation, but be able to identify those controls up front is really the first step for you to be able to automate and kind of build those systems around it. So if you don't understand your controls, you can't actually build tools that address those controls, and that's where the friction comes. At least in some kind of places I worked in. So the tools, well, we have kind of different ML governance tools, and with MLOps level 1 and level 2, and I'm kind of referring to the Google definition of it. In JP Morgan, we have our own kind of slightly tweaked version of it. Plus, obviously, kind of the monitoring tools. All of them are additional tools that need to be introduced into the operational environment and into your training environment, because most of them are missing. Now, I'm going to show the reference architecture and just kind of walk through the flow and how we kind of, thinking about it. I'm going to actually start from the environments, right? So you have the standard DevTest prod. Obviously, they have the whatever standard environment monitoring you might have in production systems. As I mentioned, we've introduced another one for experimentation and training, and it has its own different environment monitoring, just because you can do things in that environment which you cannot do in real production environment, and that environment can actually handle production data in a governed way. Then as kind of the journey starts from the whatever interactive activities, whether you do analysis or experimentation or whatever, you end up writing code. The code is essential just because you need to, the code report is essential because you need to make sure everything is captured. And that's essentially the start of the governance kind of journey. Is you know the code, you know the version of it, and you know who committed the code and how it was committed and by who, etc. So when you are experimenting, you will be accessing real training data, and you probably will be creating, or in some, depending on the problem space, you might need to create your own feature store. So for instance, in quantitative analysis, they tend to create business-specific feature stores in order to reuse them across the teams, across the applications, etc. So Not everyone needs feature stores, I realize that, but this is a general platform we're talking about here. Once the code is committed, obviously, it's a pretty standard kind of GitOps pattern where you trigger the ML ops orchestration and promotion. But unlike pipelines, the way I'm thinking about it, it's actually an engine. So, and the difference there is a pipeline has a start and finish. But an engine, as soon as you start it off, it can run and continue running there. And it's kind of that continuity is extremely important, especially when to do fancier stuff like active learning, like kind of some folks mentioned, and things like that. But we're in a governed environment, so we obviously have different policies and policy engine and evidencing at the bottom. So those mean that essentially you can express a set of conditions saying, hey, don't promote my model into higher environments unless it has certain performance metrics met, data quality known, evidencing and lineage established, and things like that. And the evidencing is obviously kind of collected throughout the process from whatever other ML governance tools that you'll be using, such as your registration of features, which are essentially the pipeline of how those features created, the data pipelines. The model repository and registry, so kind of similar concept, but for models with lineage of how the model was created, the different versions, the dependencies, data dependency, feature dependency, container dependency, and whatnot. Data-related stuff such as registration of data. So if you're using data, you need to make sure it's kind of from an appropriate source system. It has a known quality, etc. And obviously, all the new features you create also needs to be registered and governed, etc., etc. But all that should be possible to do through automations. I know there are kind of multiple vendors do quite a bit of it these days. Once you trigger the automation, you end up having a model. That's great. Now, what do you do? Well, you probably want to kind of containerize it just to kind of make sure all the dependencies are captured, because you don't want to pull anything during kind of when your container is spinning up and kind of have and your Artifactory or whatever container repository you're using in your enterprise goes down. So you want to kind of make sure everything is containerized, available within your cloud environment. And yes, sorry, I didn't mention. Everything is in the cloud. So kind of make sure your kind of container repository get pulled and associate with your production environment, so you can reduce the blast radius, etc. When you get to deploy, I kind of mentioned shadow models. Well, what we are kind of introducing that is a layer on top of the application, essentially. So you have the standard applications with whatever the data stores it has, whether it's structured, unstructured, images, voice, doesn't matter. It's just data. But the layer on top we've kind of introduced is one that has this kind of multiplexer that allows you to configure what is a shadow model, what is your active model. If you have ensembles, what are the set of models that represent your ensemble, so that the router can then route the answers kind of within the ensemble. You can kind of, this is extensible, so you can actually put continuous learning there, so you can actually have the model that will be continuously learning and doing kind of stuff within that inference engine. But all of that kind of stuff needs to be monitored. The idea is, that's the additional stuff that kind of we need to make sure we're kind of bringing into the picture. Data monitoring and model monitoring. And it's not just, passive monitoring. Oh, I have an issue, I'm going to raise a ticket for my operators to address. We actually want triggers. I was saying that MLOps orchestration promoting it's an engine is because it's an engine that can be triggered to retrain a model and redeploy it to production, because that's how you get to mitigate some of the risks of having a stale model or drifted model, etc. Did I miss anything here? So, and obviously everything is through evidencing. You have, you know everything, why it was happening, how, who did it, etc. I think this is kind of where our journey is currently in JP Morgan. Kind of, there's a slightly more or less abstract version of this, and I actually kind of gave similar presentation in the JP Morgan AI Summit a couple of weeks ago. So I'm happy to take any questions if you have, and as the time permit.
Thank you for your interesting presentation. I really like the continuous learning that you had. I wonder if you have the full cycle automated without having human in the loop. I understand some applications you may be able to get the ground truth, but other than that, there are so many models that requires to be checked by actual human to verify. So have you considered that in your?
Yeah, so kind of, I'm going to refer to the Google's MLOps kind of model just kind of to level set some of those. So you're kind of referring to the MLOps level 2 where you can actually deploy to production as well. We're at this point in time roughly in MLOps 1 going towards the 2. But the idea is that if you have actual evidencing, the policy can actually be plugged to inspect the evidencing, and you have the actual rationale. And for some model types, the governance people will allow that's my assumption. We're going to check it in a year. I'll come here. The assumption is through evidencing we can convince the government saying, hey, you don't need people to approve it because what they're going to do, they're going to read this, and do the check boxes. So we can do it through automation. Let's move on. That's the assumption. Cool. Works. Thank you.